Welcome back. Today's topic is caching, probably the single highest leverage performance idea in all of software. It's why the second visit to a website loads instantly, why servers survive traffic spikes, and, fair warning, it's also the source of one of programming's most famous headaches. The idea fits in one sentence. If computing an answer is expensive and you'll need the same answer again, keep a copy somewhere fast. That's it. A cache is a small, fast store sitting in front of a big, slow one. Think about a product page. Rendering it might mean 3 database queries and some computation, say 100 milliseconds of real work. Now 10,000 people view that product today. Same queries, same answer, 10,000 times. Do the work once, keep the result in memory, and serve the other 9,000 odd requests in a millisecond each. You've made the site faster, and you've protected your database from 99% of that load. Speed and survival. Caching buys both. 4 words you'll use forever. A cache hit. The answer was in the cache. Fast path. A cache miss. It wasn't, so you do the real work. And, crucially, store the result on your way out so the next request hits. Cached copies can't live forever, so every entry usually gets a TTL, a time to live, say 60 seconds, after which it expires and the next request recomputes it. And because caches are small by design, when one fills up it evicts entries, typically the least recently used ones. Hit, miss, TTL, eviction, that's 80% of every caching conversation you'll ever have. Here's the mental model that ties the whole topic together. Between your user and your database, there isn't one cache. There's a chain of them. The browser itself, a CDN at the network edge, an in-memory cache next to your server. Even the database caches internally. A request travels down this chain, and any layer that has the answer stops it right there. The closer to the user it stops, the faster it feels. Let's walk the 3 layers you'll actually work with. Layer 1 runs on your user's own machine, and you control it with HTTP headers. The big one is cache control. This first header tells the browser, keep this file for a year, and don't even ask me again. It's immutable. You can afford that for assets because build tools put a fingerprint of the content right in the file name. Change one line of code, the hash changes, the file name changes, and browsers fetch the new file. Old version cached forever. New version picked up instantly. The cleverest trick in web asset deployment. For things that do change, there's validation. The server sends an E tag, a fingerprint of the response. Next time, the browser asks, I have version ABC 123. Still current? If yes, the server replies 3.4 not modified, an empty response that costs almost nothing, and the browser reuses its copy. And here's the part that matters for you. These headers come from your responses. As a backend developer, they're your remote control over every browser on Earth. Misconfigure them, and users get stale apps or needlessly slow ones. Layer 2. The CDN, the Content Delivery Network. Your server lives in one place, your users don't. A CDN keeps copies of your responses on hundreds of edge servers around the planet, and each user is served from the nearest one. Physics is physics. A round trip across the world takes hundreds of milliseconds no matter how good your code is. Serving from a node in the same city cuts that to 20. CDNs respect the same cache control headers you just learned, so one skill configures 2 layers. Static sites and framework platforms lean on this so hard that many production sites are effectively 100% CDN served, requests that never even reach your backend. Layer 3 lives next to your server, and the standard tool is Redis. Remember it from the key value family in video 1? A blazing fast in-memory store, perfect for caching. This snippet is the most common caching pattern in existence, cache aside. And it's exactly the hit-miss logic from earlier, in code. Try the cache first. On a hit, return immediately. On a miss, query the database, store the result with a 60-second TTL, return it. Every request for the next minute is a 1 millisecond hit instead of a database round trip. Notice the key design, product : plus the ID. That naming discipline is what lets you find and invalidate entries later. This layer is where teams cache expensive query results, rendered fragments, session data, rate limit counters, anything hot. Now the famous headache. There's a classic joke. There are only two hard things in computer science: cache invalidation and naming things. Here's why it's earned. The moment you cache something, you own a second copy of the truth. When the original changes, a price drops from 49 to 39, your cache happily keeps serving 49 until it expires. A customer sees the wrong price. That's the cost of caching, staleness. 3 ways to manage it. 1. Short TTLs and simply accept a bounded window of staleness. Fine for view counts, dangerous for prices. 2. Explicit invalidation. When your code updates product 42, it also deletes the cache key for product 42. Precise. But you must remember every single write path, and the one you forget becomes a bug report. 3. Stale while revalidate. Serve the old copy instantly while refreshing it in the background. Users get speed, data gets fresh a moment later. You'll meet it everywhere. It's an official cache control directive you can set from your backend. And the same philosophy powers client data fetching libraries like SWR and React Query. The rule of thumb: cache aggressively where staleness is cheap, cautiously where it's expensive, and always know which one you're dealing with. Recap. A cache is a fast copy in front of slow work. It buys speed and protects your systems. Know your 4 words: hit, miss, TTL, eviction. Caching happens in layers. Browser, CDN server, and HTTP headers steer the first 2. Cache aside with Redis is the workhorse pattern on the server. And invalidation is the hard part. Choose TTL, explicit deletes, or stale while revalidate deliberately. Next video is our last in this batch. Webhooks: how services tap your app on the shoulder when something happens. See you there.